Hello, my dear class 9 students. Welcome back. So today we'll start with the third part of the chapter 4, science, that is structure of the atom. Okay. So in the last class, we have discussed about the Bohr model of the atom, right? The Bohr model of the atom. Now, Rutherford, in the Rutherford model of an atom, okay, he failed to explain the stability of atom. Failed to explain the stability of atom. Clear? So, like I said, the structure of atom, it's all like a journey, okay? So, now since Rutherford failed to explain the stability of the atom, now in order to improvise this model, Bohr came, right? He gave a well structure of an atom. Now, Niels Bohr, okay? Bohr, he was able to explain the stability of the atom, right? So now, according to Bohr, okay, according to Bohr, there is a nucleus. There is a nucleus in the center, right? And electron revolve around in a fixed orbit, right? So these are orbits. Right. So this is the nucleus. In here we have the neutrons and protons, right? And the neutrons and protons together, that is known as nucleons, right? So this is the nucleus. And according to Bohr, he said that electron revolve around this orbit. And these orbits are also known as energy shell. Energy shell. Clear? These orbits or shell. Okay. This one is known as shell or orbit, and this is also the other word is energy shell. Okay. So they are represented by K, L, M, N, and it goes on. Okay. Or 1, 2, 3, 4. Clear? Now, according to Bohr, when electrons revolve around this orbit, okay, they do not lose energy. Clear? They do not lose energy. Until unless they are in this orbit, they do not lose energy. In this way, he was able to explain the stability of the atom, which Rutherford failed. Okay? So, students, now we will discuss about how electrons are distributed in this orbit. Okay, how electrons are distributed in this orbit. Okay, my dear students, now we will discuss about the distribution of electron in an orbit. Okay, so as like I have said, this is the nucleus and this is the first shell, right? The first shell. So now there is a formula. Okay. In order to know the maximum number of electrons, okay, in order to know the maximum number of electrons in a shell, okay, in a shell there is a rule and there is a formula, and this is the formula, okay, 2n square, 2n square. Now for K shell, okay, for K shell, that means for the first one, for K shell, let's see how many electrons can be accommodated, can survive here, okay, can be accommodated. So now here n means this is the first shell, right? This is the first shell, so students will write 1 square, okay? So we'll have 2 into 1 square means it is 1, so we have 2. So in the first shell, the maximum number of electrons that can be accommodated would be 2. Okay, so let's say these are the electrons, okay? So in the first shell, the maximum number of electrons that can be accommodated would be 2, okay? Now let's discuss about the second shell. Okay, so this is K shell and this is L shell. Now let's see how many electrons can be accommodated in the second shell. Okay, now for L shell, okay, for L shell would be 2n squared. The same formula, okay, my dear students, same formula. So we have 2. Now here n would be 2, right? See, this one would be 2. So we'll write 2 square. So it will be 2 into 2 to the 4. So we'll have 4 into 2, 8. Clear? So in the L shell, okay, in the L shell, the maximum number of electrons that we can accommodate would be 8, okay? So we can write, see, 1, 2, 3, 4, 5, 6, 7, 8. Clear? Now, let's discuss about the M shell, okay? See, K, L, M, right? Now, we are done with the K and L. Let's discuss about the third shell, okay? Now, M. Now, for M shell, okay? For M shell, the formula is same, students. You have to keep this formula in mind, okay? 2n squared. Now, here n would be, see, n can be 1, 2, 3, 4. Clear? Now, the n here would be 3 because we are going to calculate for the m, right? So it will be 2 into 3 square. Clear? Now, 2 into 3 square would be 9, right? So it will be 18. So in the M shell, we'll have the maximum number of electrons which we can accommodate would be 18, okay? Similarly, we can do for the N shell as well, okay? K, L, M, N, okay? Now, for N shell, we can write for N shell, okay? For N shell, what we can do is 2n squared. Now here n would be 1, 2, 3, 4, right? So it will be 4 into 4, 16. See, so the maximum number of electrons that we can accommodate here would be 32, okay? So it will be 2, 8, 18, 32. Clear? K, L, M, N. Okay. And then the formula is 2n squared. So keep this in mind. So this is the first rule. Okay. The first rule is by using this formula, we can know how many the maximum number of electrons that we can accommodate in a shell. Okay. Now, students, the second rule, okay, the second rule would be, now, how electrons are filled, okay, let me tell you. See, we cannot just fit the electrons like from here, okay. The electrons are filled in a stepwise manner, okay. They will start from the first shell, okay. So, electrons are filled in a stepwise manner. Clear? See, this is very simple. Now, electrons are filled in an orbit in a stepwise manner. Clear? So we are done with the first two rules. That is, the first one is just by using the formula, we can know the maximum number of electrons which we can accommodate in a shell. Now, the second one is electrons are filled in a stepwise manner. Okay, it is not random. We cannot just put any electrons and fill here, okay? It is, we follow the stepwise manner. They will start from the lowest energy to highest energy. Clear? Okay, now students, the third rule would be the maximum number, okay? The maximum number. The maximum number of an electron in an outermost shell. valence. Okay, the outermost shell is also known as valence. In N, outermost shell is 8. Clear? 8. So this is a 3 simple rule to know how electrons are distributed in an orbit. Okay. So this is the second rule. This is the third rule. The first rule is which I have explained by using this rule. Clear? No, by using this rule, we can know how many electrons we can accommodate. Okay, the maximum number of electrons. So you can note down this one, and I'm sure you are clear with this rule. Clear? Now students will see some structure of atom. Okay, we'll see for the at least you should know like the first 20 elements. Okay, class 9, at least you should know the first 20 elements and their atomic number. Okay, so now we'll see the structure of some elements. Okay, so my dear students, elements. Okay, let's start from hydrogen. Okay, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Clear? Now fluorine, neon. Okay, so this is till 10. Now we have sodium, magnesium, aluminum, silicon, phosphorus, chlorine, and argon. So this would be till 18. Okay, so this is the element, and the atomic number would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so students, given here are the symbols. Okay, symbols of the first 18 elements and their atomic number. So this one is the atomic number. Okay, the number here are the atomic number, and these are the symbols of the first 18 element. I have written till argon. Okay, this is argon, chlorine. Clear? Now let's start from hydrogen. Okay, for hydrogen, if you have to draw the structure of hydrogen atom, okay, then it is very simple. We have a nucleus here, and then see, hydrogen, it has the atomic number is just 1. Okay, that means 1 protons, right? 1 proton. That means it has just 1 electrons. So that means it will be like this, students. Clear? In the K shell, it will have just 1 for hydrogen. Clear? Now let's see the structure of helium. Okay, helium. Now helium, since the atomic number is 2, right? So in the K shell, see, so this would be the structure of helium. Okay, helium. Now students, let's see for this lithium. Okay, let's see the structure of lithium. Now in the K shell, the maximum number is 2, right? But lithium, it has 3 electrons. Okay, lithium, it has 3 electrons. So now in the K shell, there is just space for 2 electrons, and it is already filled. So in that way, we'll draw the second shell, that is L shell. Okay, so for lithium, 3. Okay, for lithium, it will be 3. So this is the structure of lithium. Now let's draw the structure of sodium. Okay, sodium. Now sodium, it will have 11 electron, right? 11 electron. So for sodium, let's draw the structure here. Okay, for sodium. So we'll have a nucleus here. Clear? Now we all know that in the first shell, it has a place only for 2 electrons, right? Now what about the second shell? Just now we have discussed the maximum number of electron would be 8, right? 3, 5, 6, 7, 8. So students, now you count, okay? We have 8 plus 2 means 10, right? Now, sodium, it has 11 electron, right? So we have 2 and then we have 8. That means we have to draw another shell here, 1. So 2 plus 8 plus 1 means 11, right? 2, 8, 1. Okay, and this would be the configuration for sodium. In the K shell, sodium has 2 electrons, right? In the L and then M. So in this way, students, you can draw the structure of any elements, okay? Any elements. So see, I have drawn I have shown you for hydrogen, lithium, sodium, right? So likewise, you can try for the rest, okay? You can draw for the next. Now, okay, for magnesium, it's 12, right? So you can just add 1 here, okay? You can just add 1 electron here, then it becomes the structure of magnesium. Now, if you count here, it will be 2, 8 plus 2, it will be 12. In the K, L, M. So this is the electronic configuration of magnesium. Okay, so in this way you can draw the structure of any atom. Okay, any elements. Okay, so students, that is all for this structure, and the next topic would be isotopes. Okay, isotopes. Now, students, isotopes. The meaning of isotopes is atoms of an element, okay? Atoms of the same element. Atoms of the same element if the mass number is different, okay? If the atomic number is same, but the mass number is different, then it will be isotopes. Now, I'll give you an example, okay? I'll give you an example. Now, students, atomic number is represented by Z, okay? And here we write what? We write the, okay, I'm sorry, students, this is Z is the symbol of element, okay? This is the symbol of element. Symbol of element, okay? This is the symbol of element, and this is the atomic number, and here we write the mass number, okay? So, I'll show you an example of isotopes. Clear? Now, isotopes means having the same atomic number but the mass number is different. Okay? So, we have hydrogen. So, atomic number is 1, right? We have 3 isotopes of hydrogen, okay? So, see. The atomic number is same, right? This is the symbol of an element, that is hydrogen, okay? Now this is the atomic number, okay? But this is the mass number, this is another mass number, this is another mass number. Okay? Protium, deuterium, tritium. Clear? So see, we have the same element, the atomic number is same, but the mass number is different. So that is an example of isotope. Clear? Now, the last topic would be isobar, okay? Isobar. I'll just give you an example, isobar. Isobar. In isobar, we have 2 different elements, okay? 2 different elements. Let's say we have argon and we have calcium, okay? Now, their atomic numbers is different, okay? For argon, it is 18, and for calcium, it is 20, okay? But their mass number is same, that is 40, 40. So this is an example for isobar. In isobar, the atomic numbers are different, but the mass number is same. Clear? And in isotopes, we have the same element, atomic number is same, but the mass number is different. Okay? So you have to know the difference between the isotopes and the isobar. Okay, isobar means just the mass number is similar and the elements is different. Atomic number is different. Okay, now this is the mass number, and mass number is the sum of protons and neutrons. Clear? So I'm sure you are clear with all this. Note down all the points that we have discussed, and also you have to draw the structures. Okay, for this chapter you need practice. Without practice you will get confused. Clear? So I'll see you in the next class with a new chapter. Thank you so much.